Thanks for coming, everyone. We've got Rose, Dave, and Josie today to talk about all things related to pets and pesticides. They all have their own slides, so I'm just going to go straight in with Josie first.
Thanks so much. Thanks for coming. I'm Josie. I'm Head of Policy and Campaigns at PAN UK. I think I know most of you. Just to say, all of the pets in this presentation, apart from these three on the front cover, belong to a PAN UK staff member. So just wanted to make that clear. So PAN UK started looking at pet poisonings in 2022, and we published a major report on the topic in last November. So there are two key ways in which pets are directly exposed to pesticides. So not including diet, which counts as indirect exposure. So our report was very much split into two halves. And the first half looked at what we call accidental poisoning. So like humans, pets are constantly exposed to pesticides that are used in the external world. And this can lead to two types of poisoning for pets. So you can have acute pesticide poisoning, which is adverse health effects from a single exposure or from multiple exposures, but over a short period of time, so usually under 24 hours. There's also chronic pesticide poisoning, which is exposure to pesticides over a long period of time, multiple exposures, leading to the development of long-term illnesses such as cancer. So when we say accidental poisoning, we're referring to both acute and chronic, since in both cases, pets are just caught in the crossfire. So that's the first half of the report. The second half, in contrast to accidental poisoning, looked at pesticide active substances that are used in veterinary medicines and then intentionally given to pets. So today I'm going to first talk about accidental poisoning before we move on to looking at vet meds. And as Amy said, we're very lucky to have Professor Dave Goulson and Rosemary Perkins, who are going to present some of their research on the topic. So what do we know about pets and pesticides in general? Sorry, let's went forward. Amy, you can hear me all right? I'm a bit jerky from
you're fine.
From my perspective. Okay, great. So what do we know about pests and pesticides? So we know there's been a huge rise in pet ownership in the UK since the pandemic. 52% of adults now have at least one pet. There are 10 million dogs, 11 million cats, and 1 million rabbits in the UK, pet rabbits, obviously. So this is no small niche issue. We also know that pesticides have the potential to cause serious harm to human health. They include carcinogens, developmental and reprotoxins, endocrine disruptors, and neurotoxins. Some pesticides are acutely toxic. So while pesticides are classified using human health impacts, it is possible and perhaps even likely that they also present a very similar risk to animal health, particularly in the case of mammals. What else do we know? We know that there's a huge amount of anecdotal evidence. So PAN UK is regularly contacted by people who believe their pet was previously poisoned by pesticides, and there's nowhere to send them, to be honest. And then through our local level work on the Pesticide Free Towns campaign, we regularly come across articles in the local press about pets being poisoned by pesticides, especially dogs. So there's plenty of anecdotal evidence that there is a problem, but almost no data. The only data we do have is from something called the Veterinary Poisons Information Service, the VPIS, and that was founded in 1992, and it works to fill the data collection void on poisonings. It runs a helpline for both vets and pet owners, but both have to pay a service fee to be a member. So they don't have many owners, to be honest, but around 80% of vets in the UK are members. They've collected 30 years worth of data consisting of around 300,000 cases, but the data is not publicly available, unfortunately. But the figures from their latest annual report show that around 7% of the poisons that are reported to them are caused by something classified as a pesticide. Numbers are on the rise. There was a 55% increase in pesticide-related poisonings over 2 years. And again, these only reflect the poison cases that are reported to them, so is likely to be an underestimation. What we don't know is going to take much less time because the answer is everything else. There's very little research conducted on the impact of pesticides on pets. There's no systematic or comprehensive monitoring of the issue in the UK by any public body. So there's a lot we don't know. So looking specifically at accidental pet poisoning, so like humans, pets are exposed to pesticides in a wide range of ways in a variety of locations. We have more than 400 active substances approved for use in farming and 40 for use in amenity, so public spaces like parks and playgrounds, streets, hospitals. These actives are packaged and sold as thousands of different products. Then you've also got parasiticides, as I say, veterinary medicines, which contain actives. Animals also consume pesticides through their diet. So as with humans, there are real concerns about the cocktail effect, which is when chemicals, when combined, can become more harmful than when considered alone. So we just need to bear this in mind as we look at the individual routes of exposure. So in terms of individual routes, urban spraying is a big one. So herbicides, mostly glyphosate, but also some other highly hazardous pesticides such as 2,4-D and MCPA. Local councils are the main sprayers of pesticides in public spaces, in parks, in playgrounds, road verges, pavements, but other landowners also use them, university campuses, hospitals, schools, private housing developments, etc., etc. There is no obligation for those using pesticides in urban areas or rural areas, actually, to inform the public either before or after spraying has taken place. So it's impossible for pet owners to know when an urban space has just been treated. Dogs are particularly at risk because they spend time in parks and other green spaces. They consume pesticides orally by eating grass, licking the ground, drinking from ponds and puddles, and they're exposed via dermal absorption, so absorbing through the skin from lying on treated ground. We had a few case studies in the report, but just to give you one, this is Cindy, a Rottweiler from Manchester. In 2017, we were contacted by her owner. She had to be put down due to suspected glyphosate poisoning. She was a fit and healthy 8-year-old dog, but developed sudden neurological symptoms such as cluster seizures after dozing for an hour on the grass. She weighed 40 kilograms, which is roughly equivalent to a 12-year-old child. But she had to be put down just 36 hours after her symptoms first appeared. But because there was no indication that her symptoms were due to chemical exposure, her owner had her body cremated without any further testing. And then it was only when he went back to the same park a few weeks later and he saw those telltale, the brown strips that, that you get from when a herbicide has been sprayed, which you don't really notice until you know about them, and then you can't stop seeing them. And then he thought, oh my God, I wonder if she was poisoned. So he contacted his local council and discovered that glyphosate-based weed killer had been sprayed by the contractor on the paths in the park earlier the same day, and that they had accidentally sprayed the grass around the paths as well, and that Cindy had been lying with a kind of soft, hairless skin on her stomach, making contact with the grass for about 60 minutes, which is sadly what led to Cindy's death. But there was just no way for her owner to know that the park has been sprayed with pesticides, and this is an issue in urban areas. So back to the routes of exposure. So the countryside is obviously a big one. As we all know, crops can be treated up to 20 times in a growing season, sometimes more. Spray drift is a real problem for pets, rural pets, spending time in gardens that are close to agricultural fields, and even more so for those that live outside, such as rabbits in hutches. Pesticides also run off from treated fields and expose pets that drink from rural rivers and ponds, and also dogs swimming in contaminated water. They eat treated grass and plants and can even absorb pesticides through their skin just walking through treated crops. Gardens are another major route of exposure. So again, cats and dogs and rabbits directly exposed by consuming. They actually consume garden pesticides in some cases and also eat treated grass and plants. Cats are particularly at risk because owners often don't know where their cats are. They'll spend time in multiple different gardens, usually out of sight. So if a cat comes home experiencing poisoning symptoms, it's very difficult for an owner to know that the cause is pesticides, let alone identify which particular chemical is involved, which is really important for vets to identify treatment. Pets also manage to get into excess or old pesticides that are stored in unsuitable places like sheds. Slug and snail pellets can be particularly harmful. So obviously the government banned metaldehyde a few years ago, but the replacements iron phosphate and ferric phosphate, whilst not quite as toxic, can still be harmful to pets. They can be consumed directly by pets, or pets can be harmed when they eat slugs or snails that have been poisoned. And these products are so toxic that pet owners are advised by the HSE to thoroughly wash the area after use to make sure that any chemical residue has been removed. Finally, rodenticides are particularly harmful because they're designed to kill mammals, so they are particularly high risk for pets. And they're also designed to attract rodents, so they give off odors, which can also be appealing to pets. Sometimes pets eat bait that's been carried by a rodent out of a bait box and then dropped, or they eat the poisoned rodents themselves. So, sorry, that's Cindy. So here are some of the most common signs of acute poisoning symptoms, in dogs and cats. They can range from mild to life-threatening, really depends on a range of factors such as the type of pesticide involved, the route of exposure, the amount ingested or absorbed, and the size of the animal. And symptoms can be seen in the first few minutes or can be delayed for up to a few hours or even days. This is obviously talking about acute poisoning rather than chronic. So veterinary pesticides, and by the way, this is Amy's incredibly cute dog, Rosa. so looking at veterinary pesticides, so there are roughly 1,000 products approved for use on cats, dogs, and or rabbits in the UK. 80% of dogs and 82% of cats are treated regularly with vet meds containing pesticide active substances. They contain a range of highly hazardous pesticides, including imidacloprid, which is a neonicotinoids, and fipronil, both of which are highly toxic to bees, and also substances like permethrin, which is a carcinogen and an endocrine disruptor, which can be harmful to human health and pet health. They're given either as tablets or applied as spot-on treatments or collars, and some are over the counter, whilst others are prescription only. So I'm going to hand over to Dave and Rose in a minute to talk about the environmental impact, but just quickly, there is evidence that parasiticides can be harmful on the health of pets, and it can lead to acute poisoning. Sometimes the fault lies with the product itself, and other times it's due to the label instructions being ignored. So, for example, rabbits are allergic to fipronil, cats are allergic to permethrin, but they are common actives found in medicines for other species. So sometimes they're administered improperly. There's a really good example. There's something called the Seresto flea collar, which is a product originally made by Bayer. It contains imidacloprid and flumethrin, which is a pyrethroid. And since 2012 in the US, the Environmental Protection Agency has received more than 100,000 adverse incident reports, including over 2,500 pet deaths and hundreds of incidents involving human harm. But the collar remains approved for use in the US and the UK, and it's recommended by PDSA and other animal charities for use, which I just find mind-blowing. There can also be impacts on human health. So owners are advised to take precautions after they put on spot-on treatments like wearing gloves and to not touch the treated area for 24 hours. But the majority of us, we know, we're in constant regular physical contact with our pets, and they're allowed to spend time on beds and couches. And so it's very unlikely that the pesticides are contained to the target animal. That's even less likely when you have small children in the home. So stopping a toddler from cuddling or playing with a pet is almost impossible, especially when the treatment has to be administered every month. And young children will often touch pets' bedding, toys, or clothes, all of which will have come into contact with chemicals. So one very marked study estimated that toddlers are 5 times more exposed than adults to fipronil when it's used on pets. And that's really interesting because fipronil is banned in medication for animals that are intended for human consumption because of the risks it poses to human health, but is regularly used in vet medicines for pets without sort of a second thought. So at that point, I will hand over, I think, to Dave, and I'm just going to finish off at the end. But over to you, Dave. Let me stop sharing, obviously.
Thanks, Josie. When you stop sharing, I'll start sharing.
Yeah, sorry, Dave.
That's all right.
Just pressed it. Hopefully that's okay.
Yeah, there we go. I'll get there in a second.
Okay. Yeah, I'm good at technology unless I have 30 people on a Zoom call looking at me, and then I can't use it.
I know the feeling. Yeah, suddenly all fingers and thumbs. Hang on. There we go. Hopefully you can see a bee slide, which might seem slightly irrelevant. So I'm going to introduce Rosie's work on the environmental fate of these spot-on flea treatments. But I thought it might be useful for some of the people here, at least, to explain how I came to be interested in that area from a background of spending 30 years studying bees. And this isn't just an excuse for me to have a little wander down memory lane and waste your time. I think actually it's useful context for understanding the risks associated with the use of these chemicals on dogs and cats. So as I say, my background is bees and bee conservation, trying to work out why they're declining and what we can do about it. Bees are, many of them, in decline. This is just an example, and sorry for those of you that have heard me talk before, as this slide is a tiny bit tired, but this is the shrill carder bumblebee, lovely little thing. Used to be common pre-1960 in the southern half of Britain, but it's disappeared. And this, I could show you maps for a dozen other species which have done similar things. So this bee's clinging on in a few sites. By 2000, it was down to about 6 sites in the south of England. And actually, since 2000, it's gone extinct on Salisbury Plain and the Somerset levels. So it's disappearing. And because of concern over bee declines and trying to do something about it, back in 2006, I started a charity. I'm not here to plug the charity, but it's called the Bumblebee Conservation Trust, to try and do something about the decline of bumblebees. And very early on in the life of the trust, we started being contacted by members who were getting really exercised by what they believed to be the impact on bumblebees of pesticides, particularly neonicotinoids, which at the time were a fairly new class of pesticide. And so this was 2007, and up until that time, I'd never shown any interest in working on pesticides at all. But we were getting a lot of demands from our members that we should look into this. And so I did a bit of reading and came to the conclusion that actually there was something to be concerned about here. So what are these neonicotinoids? Well, they're neurotoxins. They're synthetic derivatives of or variants on nicotine. There are different versions of them. There were 5 that were used in Europe, with imidacloprid was the first introduced to the market. And also on the list there, I've added fipronil, which technically isn't a neonicotinoid, but it's a very similar chemical with a similar mode of action and similar properties. Now, what people were really, the bee world became concerned about was the use of these crops in arable farming, initially focused on their use on flowering crops. So the way these chemicals are used is they're stuck on seed as a seed coating that before the farmer buys his seed. So there's funny blue dots. That's oilseed rapeseed coated in pesticide. And the idea is that the farmer just sows the seed in the ground, and these are water-soluble chemicals. They dissolve into the soil moisture, and then they're sucked up by the little seedling as it grows, and they're systemic. They spread through the plant, and they make the whole plant poisonous to insect pests, so the farmer doesn't need to do anything else to protect his crop. Sounds pretty neat, but the obvious downside is they get into the pollen and the nectar of the treated crop. And French beekeepers noted really early on in the use of these chemicals that their bees were dying if they put them near sunflower fields. So it seemed like there was something to be concerned about here. In fact, it turns out that this method of applying these pesticides was pretty sloppy. It was billed as being a really good way of targeting the pesticide to the crop, stick it on the seed. But actually it turned out, so this diagram here is meant to show you the environmental fate of a dressed seed used by an arable farmer. This could be a cereal crop, a sunflower crop, an oilseed rape crop, any arable crop. So the seed covered in the pesticide is sown in the ground, and as I say, the chemical dissolves into the soil water and then is supposed to be sucked up by the little crop as it grows, and that protects the crop. But it turns out on average, only about 5% of the seed coating goes into the crop. Most of the pesticide is left in the soil. From there, it can be taken up by the roots of any wildflowers growing in the crop or next to the crop, if the farmer's sown a wildflower strip, or by the hedgerow shrubs that might flower, things like hawthorn and so on. Or they might leach into rivers because these are water-soluble chemicals that are quite persistent. They last for months or years in soil. So one way or another, it seemed quite likely that these chemicals might be getting into bees, either through their use on flowering crops or because of contamination of the soil, which is then contaminating wildflowers and so on. So back in 2010, we decided to do a little experiment to see if these things were really harming bumblebees. So I should have said the defense of the company that make these chemicals, when you point out that they're contaminating the environment, is they say, oh, well, the amounts are really small. They're nothing to worry about. The amounts in the pollen and nectar of a sunflower crop are a few parts per billion. The amounts in the soil are similar. The amounts in rivers are similar. It's nothing to worry about. It's harmless stuff at those kind of concentrations. So we wanted to know if that was really true. We did an experiment with bumblebee nests, which, sorry if this is a bit wordy, but basically we got a bunch of bumblebee nests, and I will come to pets in a second. And we fed them on food, which we'd laced with imidacloprid, one of these pesticides, to mimic the concentrations found in the nectar and pollen of unoilseed rape crop. And we had another treatment with twice that dose for good measure. And we had control nests with healthy food. And having exposed the bees to the pesticide for 2 weeks, mimicking them feeding on a flowering crop for 2 weeks, we put the nests outside and we monitored them to see how they did, and we weighed them. And the control nests, the ones without pesticide, grew much bigger. And this was, I guess, the point at which I started to think, okay, there does seem to be some issue here. And particularly when we looked at the number of queens produced by the nests, the control nests produced quite a few queens, and those treated with the pesticide, either the low or high dose, produced hardly any. And queen production is really vital for bumblebees. If they don't produce queens, then there's nothing to start nests the following year. And those, even the low dose, produced 85% fewer queens than the controls. So given that these tiny doses really do seem to be enough to be harming bees, the evidence of kind of global contamination with these pesticides is really quite worrying. This map shows you each dot is a honey sample collected from somewhere in the world. This was a study published in 2017. Each dot represents a sample of honey, and the color of the dot tells you whether it was contaminated with a neonicotinoid pesticide or not. And the white ones were clean, which is about 25% of those samples. But you can see that basically honey, which is obviously nectar collected by honeybees, from around the world, every continent is frequently contaminated. And these concentrations are very similar to the ones that we found that were enough to harm bumblebees. 75% of the world's honey contains a neurotoxin designed to kill insects, which is pretty concerning. So I mentioned in passing contamination of rivers, and as part of the sort of debate that blew up over these chemicals, which I should say led to them being banned from use in farming by the European Union in 2018. One of the concerns was river contamination. As I say, the chemicals contaminate soil water and they can leach into ditches and streams and lakes and so on. And Matt Shardlow from Bug Life posted this map of river contamination with imidacloprid about 10 or so years ago. I can't remember the exact year. And this was mainly used as evidence that our rivers were being contaminated by agricultural use, which tends to be heaviest in the south and the east. But one thing that was odd about this map is that there seems to be, so I should say the green sites were clean, and the yellow, orange, red are various levels of contamination with imidacloprid. There seem to be sites that were contaminated with this pesticide that are miles from any agricultural use. So up in bits of Scotland, where you wouldn't expect these chemicals to be turning up in rivers. And so this led somebody, and I haven't got a clue who it was, to suggest that maybe, it might have been Matt, that maybe this was coming from pets, because if you looked at the licensed uses for imidacloprid, aside from arable farming, there were very few, but one of the obvious ones was that you could drip them on the neck of your dog or your cat. And clearly, if your dog then goes for a swim, that could explain why places in the remote highlands of Scotland were contaminated with these pesticides. This gathered enough interest that a few years later, the Veterinary Medicines Directorate decided they ought to investigate. And they gave a grant to me, which ended up funding Rose, to look into what was the environmental fate of these chemicals when applied externally to dogs and cats. At which point, it's over to Rose to tell us more about what the answer to that is. So Rose, hopefully you can share your slides. I'll stop sharing. Over to you.
Thanks, David. I'll just get up and running with my slides. Right, can everyone see that?
Yes.
Great. So yes, thank you very much for inviting me to speak. I'm always happy to talk about our research. My name's Rosemary Perkins. I'm a vet and a PhD student at the University of Sussex. So I'll be talking about environmental pollution from fipronil and imidacloprid used in pet flea treatments. So my research focuses on pathways from pets to waterways, basically trying to figure out where these products go after we apply them. So that's what I'll be looking at today. And the picture on the right gives a clue as to where some of it is going. So looking at the history of these products, spot-on flea products containing these pesticides, or parasiticides as they're called when used to treat parasites, first appeared in the mid-90s. They were pretty revolutionary when they first appeared. Before this, we had relied on an assortment of fairly unpleasant short-acting powders and shampoos to deal with flea infestations. And by comparison, these are incredibly convenient and effective. You just apply a few drops to the back of the neck and it spreads across the skin and coat, and it has efficacy against fleas and or ticks for about a month. In fact, they're so convenient and effective with no apparent real downsides, or so we thought, that we started applying them even before there were signs of fleas to prevent infestations, which makes sense if there are no downsides. And this has become a very popular and widespread approach to flea control. So if we fast forward to a few decades to the present day, as Dave was saying, we're now finding widespread pollution with these chemicals in waterways, despite them no longer being used in agriculture. So there's no recorded use since 2016, and they were banned in outdoor agricultural use in 2018. Just to give an idea of the severity of this pollution, this recent study looked at over 100 contaminants of emerging concern across the Thames catchment and identified imidacloprid as being the chemical of greatest concern based on how frequently it was detected and the levels that were measured. That study didn't include fipronil, but other studies have put it at the top of the list of pollutants of concern as well. So we know these chemicals are out there and occurring at very concerning levels, but how are they getting there? This report from the UK water industry was published last year and helped to fill in some of the gaps. So they found high levels of fipronil and imidacloprid in wastewater effluent and downstream of sewage treatment works across the country, so demonstrating that they are in wastewater and very little is removed through treatment. For example, concentrations of imidacloprid were on average 5 times higher downstream of sewage discharge than corresponding sites upstream. So we know these pesticides are entering rivers through wastewater, but how are they getting into wastewater? So a number of potential sources have been suggested, ranging from traces in imported food and clothing to ant and cockroach bait, but attention is increasingly turning towards pet flea treatments as a major source of this pollution. Historically, the assumption has always been that the amounts used on pets are too small to pose any environmental risk, and that assumption is reflected in the environmental risk assessment that these products undergo. And this doesn't just apply to the UK, this is a harmonised international regulatory framework, which doesn't require any information on their environmental fate or ecotoxicity if they're used in non-food animals. But with a pet population of 22 million cats and dogs, many of which are now receive routine monthly treatment, the amounts add up pretty quickly. And there are multiple potential routes from pets to waterways. This diagram from the European Medicines Agency maps out some of the pathways. And as you can see, it's a pretty complex situation. After application, these chemicals persist for long periods of time, and being fairly soluble, they are mobile in the environment and disseminate from the coat of the treated animal into the surroundings, including the pet's bedding and owner's hands, and ultimately some washes down the drain. So our goal was to measure some of these down the drain emissions and estimate how much they were contributing to measured pollution, which hadn't been done before. So we conducted a study which looked at 3 of these pathways from a group of spot-on treated dogs. Firstly, we collected hand wash samples. So we took both pre-stroke and post-stroke hand wash samples from owners. Secondly, bathing samples, and then we also took bed wash samples. And samples were taken at certain intervals after application to see how emissions changed over time and how long they lasted for. And these are the results. These graphs show average wash-off as a percentage of the applied amount for the different routes over time. Fipronil and imidacloprid were detected in all wash-off samples over the 4 weeks of the study. And one of the most striking findings was that all of the owner hand wash samples, including the baseline or pre-stroke samples, contained detectable emissions for the duration of our study. So the next step was to model overall emissions from the population and relate these results to the measured load in wastewater. So we took into account the frequency of the emitting activities for this. And we also used water industry data. So this is a slightly complicated graph, but basically it shows the flow of fipronil from pets to wastewater, where the height of the bars represents the relative load. So the green bar in the center represents usage for fipronil and flea treatments in the UK. That's made up of cat and dog spot-ons and sprays, which are the bars on the left here. And the orange bar over here represents the average load in wastewater influent, estimated from the water industry data. And the smaller blue ribbons at the bottom here show the estimated amount that passes down the drain via the routes that we looked at. So we found that all of these pathways contributed, but hand washing emissions were the largest source of emissions. And what's important to note here is that the load in wastewater is relatively small compared to the mass applied to pets. So it doesn't take much going down the drain to account for measured pollution levels. And we estimated that the pathways we looked at accounted for between 20 and 40% of the load in wastewater. And there are multiple additional likely pathways, so a lot of the amount that's applied to pets is still unaccounted for. And there were very similar findings for imidacloprid, in that the pathways we studied accounted for between 20 and 40% of the load in wastewater. And then just very briefly, we conducted a second study going through peer review at the moment. Basically, we performed a risk assessment for swimming, where we measured swimming emissions from dogs and estimated the environmental concentration for an average size pond and compared these to environmental thresholds. And we found that swimming emissions exceeded safe thresholds for at least 28 days after application. So these dotted lines along here are recognized environmental thresholds. And most spot-on product labels allow swimming after 2 days. So the take-home message is that pet flea treatments account for a substantial proportion of measured pollution, and likely additional pathways exist. And we recommend a review of regulatory and prescribing practices. So just a few thoughts on ways forward. I think this will involve some combination of the following strategies. So one of the most straightforward and quicker steps is to raise awareness of this issue amongst vets and pet owners. I'm often surprised by how few people are still unaware of this issue. I think there needs to be a shift away from blanket year-round treatment of all pets and towards a much more risk-based approach. So targeting treatment more towards higher risk scenarios, or even just monitoring and treating only if there is a problem. And a shift towards a risk-based approach has been recommended by the British Veterinary Association. Putting it into practice is not straightforward. There is resistance to change, and there's still a lot of discussion within the veterinary profession as to how we should be prescribing these products. Many are available over the counter anyway. And the question I'm often asked is, are there better alternatives? The newer tablet-free flea treatments, do they pose less risk? So these are a new class of parasiticide that was introduced in the last decade or so, called isoxazolines. They're usually administered as tablets. They're also long-acting. And the advantage of these is that they act systemically, so they don't just go into the coat and the surroundings, but they're in the blood, and fleas need to feed to be killed. And they're mostly excreted in the feces, which in many cases can be bagged and binned. So it's definitely possible that they're less harmful, but they are also highly potent pesticides, and they've had very little in the way of environmental risk assessment. And we know that at least some does go into the animal's hair. So my feeling is that a precautionary approach is the best way forward. There's some combination of shifting away from spot-ons, which we know are getting into the environment, as well as reducing overall parasiticide usage. Unfortunately, there's very little evidence of efficacy for more natural alternative treatments. And then finally, regulatory change is very important, but it tends to be the most difficult change to bring about and the one that takes the longest, not least because there is a harmonized international framework, so major changes need international agreement. It would be good to see strengthening of the environmental risk assessment required for pet parasiticides, and possibly making them prescription only. A lot of fipronil especially is sold over the counter, and there has been a call for a ban on these products. So it is a challenging and complex One Health issue, but I think NGOs can really play a vital role in helping to drive forward positive change in this area.
Amazing.
Thank you very much.
That's a nice slide to end on.
Those are all the wonderful study participants.
Oh, great. Thank you, Rose, Dave, and Josie. I'm going to hand back to Josie now. Yeah, just to wrap up that, and then we'll have questions. Don't worry.
Yeah, thanks both. That's fascinating. Can you see my presentation?
Yes, I can see my dog on the slide.
Yeah, we're still on the Rosa slide. I am pressing next, but it doesn't seem to want to move. All right, maybe it will start moving in a sec. I'll start speaking. So annoying. It's been ages on these slides. It'll come back. So yeah, one of the things I was really struck by when we started looking at this area, which was relatively new to Pan UK, is the similarities, the way the industries behave. So there's many similarities, the vet meds industry with the agrochemical industry, and obviously some of the companies involved are the same. So Bayer was big in the vet meds industry before selling its animal health section to someone called Elanco a few years ago. But we were really struck by how the agrochemical industry and the vet meds industry both use fear to sell their products. So while agrochemical companies tell farmers that they'll lose their whole crop and tell the world that we're all going to starve unless we use their products, the companies pushing vet meds tell pet owners that their pet will die and that they will get Lyme's disease. And you get all these crazy leaflets with like these kind of pictures of parasites leaning over dogs, kind of looking like they're going to murder them. So both these tactics are designed to encourage prophylactic use. So the use of chemicals before a problem emerges. In both sectors, you've got the overuse is now leading to questions around the emergence of resistance. Obviously, agriculture is further along on that. And we've now got the vet meds industry now vehemently opposing any regulation or bans of their products and pushing voluntary measures. So again, just like the pesticide industry, which was quite stark. Sorry, do you mind if I just stop sharing and see if I can get my slides to work? I'll just give it one more go. If I can't, that's fine. Ah, yes. Okay, great. Can you see them?
Yeah.
Yeah, sorry about that. So yeah, we talked about industry tricks. The regulatory system, as Rose alluded to, it's managed by the Veterinary Medicines Directorate, which actually is an executive agency of DEFRA, unlike the Chemicals Regulation Directorate, which manages all other chemicals, which sits under the Health and Safety Executive under the Department for Work and Pensions. So there's obviously a kind of bit of a misalignment there. As Rose said, the approvals process is less robust than for pesticides. So we've been quite struck, for example, a product, once it's approved, stays on the market indefinitely, unless the company responsible for marketing that product, what they call the market authorization holder, submits evidence of harm to the VMD, which seems very unlikely. So as most of you probably know, pesticides, plant protection products, an active substance gets a maximum 15 years before it has to be reapproved, but vet meds stay on forever. The environmental impact assessment is not robust. Pet meds don't even require the same level of environmental risk assessment that's needed for livestock because the amounts are deemed much smaller, although again, as Rose alluded to, no one's looking at the kind of cumulative impact of 80 to 82% of the UK's 20 million pets being treated regularly. And pets are not intended for human consumption. So again, it's argued that the impact assessments don't have to be as strong. They also focus very strongly on routes of exposure, but as Dave explained, many chemicals are both persistent and mobile, and we know from our experience of neonics in particular that focusing solely on routes of exposure is unlikely to prevent environmental contamination. And then the VMD also assesses active substances entirely independently from any other regulatory body, which is both incredibly inefficient and sort of undermining recent efforts, things like the UK chemical strategy, which is trying to deal with chemicals in the round. So approving them all under these different kind of regulatory systems that don't share any information seems ridiculous. In the UK, a pesticide active substance can be banned for use on agricultural crops because of the harms it causes, but still allowed in vet meds. So there are a number of chemicals that farmers are no longer allowed to use, but are widely used on animals. And we've talked about two big ones here, imidacloprid and fipronil, but there's a few more listed here, permethrin and nitinpyram and dinotefuran, which are also neonics. This is not a small issue. I was really struck by this figure. So in 2013, the last year for which imidacloprid was approved for use on outdoor agricultural crops in the UK, 5,400 kilograms of the active substance was used. In 2017, the amount of imidacloprid used in flea and tick treatments sold just by the top UK manufacturer totaled 4,000 kilograms of active substance. So again, if we look at the scale, this is not a small issue. And there are 5 active substances that are included in medicines for dogs and cats that aren't allowed to be used on agricultural crops. And in November, we coordinated a joint letter from NGOs calling for the UK government to do 2 things. So one was ban all pesticide active substances that aren't allowed for use on agricultural crops from being included in vet meds. And the other one is to close the loophole to stop this situation emerging in the future. So if in the future an active substance is deemed too harmful to be used on crops, then it should be automatically banned from appearing in vet meds. And this letter made the point that if these 5 actives were banned, there would still be plenty of other medicines available. At the time, I'm sure the figures have changed a tiny bit, but at the time, there would have been more than 300 alternative products available. So these are all the organisations that signed up to the letter. We spent about 3 months courting veterinary organisations, everyone from the Royal College of Veterinary Surgeons to, I don't know, animal welfare organisations. Whilst most agreed with us, they weren't as comfortable as the environmental movement calling for bans and were too cautious to sign the letter. But we did get the Progressive Veterinary Association and also the Veterinary Poisons Information Service, which I thought was very significant. And then all these other amazing wildlife organisations, which was brilliant. In terms of our recommendations, looking at accidental poisoning, it's really about similar with humans. It's about reducing pesticide use. So an immediate ban on urban use, that's a no-brainer. Reduction targets and better support for farmers to reduce rural use. Updating the risk assessment process for pesticides to include consideration of the impacts on pets. And a post-approvals monitoring system for pesticides, which again includes impacts on pets. And an adequate reporting system so that pet owners and others can report incidents of pet poisoning. Our full recommendations are in the report. On vet meds, we very much agree with Rose's recommendations. So again, improving the environmental assessment process for vet meds, funding research into less toxic and ideally non-chemical anti-parasitic products for pets, which, as Rose says, aren't brilliantly effective at the moment. Stuff around vets and pet owners and moving away from prophylactic use and explaining that it is possible to monitor a pet for parasites and only treat them if a problem emerges, particularly in the UK where we don't actually have ticks and fleas that can kill an animal with a bite. I understand in Australia, vets have told me there's things that can cause paralysis to a dog with one bite, but we don't have those kind of ticks and fleas in the UK, so we don't need to take the same kind of precautions. And supermarkets and pet shops. End the sale of veterinary medicine products for pets that contain pesticide active substances and increase the offer of less toxic alternatives. Just in terms of next steps, so on accidental poisoning, we now have a form on our website to report pet poisoning. So we're starting to monitor the data ourselves. We've got a leaflet that's going into some vet surgeries and other kind of content on screens for vet surgeries around accidental poisoning. And we've kind of built that messaging very much into the Pesticide-Free Towns, which is our End Urban Use campaign. On vet meds, we were told by DEFRA that apparently there is a section now on vet meds in the NAP, if that is ever published. Obviously, if it had been published 6 years ago when it was supposed to be, it wouldn't have had a section on vet meds. So I suppose that's a win. It would be great to see other NGOs kind of tying it to all our work on neonics, really important. And I think we're really open to collaboration and suggestions on trying to target the VMD to improve their environmental impact assessment. So I will leave it there. Thank you.
Amazing, thank you. Yeah, thanks Dave, Rose and Josie, that was really interesting.